Okay, now that we've talked about what is a system of linear equations, let's talk about how to solve a system of linear equations. For our purposes here in the 8th grade, we're going to look at this graphically. We're going to figure out where the two lines cross. How do we graph lines? Well, it's easiest to graph lines when our equation is in the form y equals mx plus b. We know the slope, we know the y-intercept. So, how are we going to do this? We're going to put our lines in slope-intercept form, we're going to graph our lines, and we're going to find the point of intersection. Let's say you're not comfortable with that. There's a number of different strategies you could use here. You could make two tables and then draw your line. And after you have your tables drawn, your tables made, you could draw your lines and find the point of intersection. The point of intersection is our solution. So let's look at a specific example. We have the system y equals 1/2 x plus 1 and negative 6 plus 3y equals negative 6. Well, the beauty of the first one is it's in slope-intercept form. I know that the slope is 1/2, and I know that my y-intercept is 1. So graphing this line will be easy. Start with b equals 1, that's my y-intercept. Then I use my slope to find my next few points. Slope is 1/2, so I rise 1 and run 2. Rise 1 and run 2. I can also match this pattern going the other way. And then I draw a line. For my second equation, since it's not in slope-intercept form, I could choose to make a table here, or I could transition it or convert it from this is standard form to slope-intercept form. So let's go ahead and talk about that. Negative 6x plus 3y equals negative 6. Well, y-intercept or slope-intercept form is y alone, so I need to get the y by itself. So to move the 6x over, I'm going to add 6x to both sides. Because negative 6x and 6x are additive opposites, so they cancel. I'm left on the left side with 3y. The right side, 6x minus 6. Those can't combine. Now, to get this y by itself, I must divide by 3. And I can't just divide one thing by 3. I must divide everything by 3. So I'm left with y equals 2x minus 2. So here, my slope is 2 over 1. My y-intercept is negative 2. So for my second equation, my green line, I'm going to start at negative 2 on the y-axis. I'm going to use my slope to find every other point. Rise 2, run 1. Rise 2, run 1. Oop, that looks like a point of intersection. Rise 2, run 1. Draw a line. This is my solution. Now, it's not enough to just circle it and say, here it is. You need to tell what that point is. So the solution to my equation is the ordered pair, 2, 2. And what's important about this point 2, 2 is if I take 2 for my x and 2 for my y and plug them back into my equations, they'll both give me true equations, true solutions. Let's try that. So into my first one, I'd have 2 equals 1/2 times 2 plus 1. I took my x and my y out, put in 2 and 2. Well, what's 1/2 times 2 is 1? Is 2 equal to 1 plus 1? Yes, it is. So, let's check my second equation. My second equation is negative 6x plus 3y equals negative 6. As you notice there, when I said x and y, I put in 2 and 2. Let's go ahead and simplify this, see what happens. Negative 12 plus 6 equals negative 6. And then what is negative 12 plus 6? Well, negative 6 equals negative 6. I have shown or proven that these both are, that 2, 2 is a solution to my system of linear equations.